Scale up. Okay. Angle of elevation is when an angle is above a horizontal line. Horizontal this way. So if I'm looking here, here is a horizontal line. Here's an angle above. That is an angle of elevation. Angle of depression is an angle below a horizontal line. Quickly. Horizontal line here. Oops, missed it. Angle of elevation, angle of depression below that horizontal line. Basically, if something is in the sky looking down, that's an angle of depression. If something's on the ground looking up, that's an angle of elevation. Okay? So, we're going to go through and name in this diagram angle 1 from my airplane looking down to my air traffic controller. You think that's an angle of depression or elevation? Depression. Angle 4, looking from my ground crew up to my air traffic controller. Depression or elevation?
Elevation.
Elevation. Alright, here, this angle 2. What do we think? Depression or elevation?
Elevation.
Elevation. See this horizontal line right here? 2 is above that horizontal line, so we have an elevation. That angle 2 is kind of like this person looking up at the bird. Okay? Angle 3, this angle right here. Depression. Good. Question. This horizontal line and this horizontal line, I'm going to tell you that they're parallel. What does that make angle 1 and angle 2?
Congruent.
They're congruent because they're alt interior. Yeah. How about, here's another horizontal, how about 3 and 4? Same thing. Cool little story. Our angles of elevation and depression are always going to be the same because they're alternate interior. Okay? More vocab stuff. Elevation is above or below line?
Above.
Above. Depression, above or below? Below. How does an angle of elevation compare to an angle of depression? What did I just tell you? Equal, because they are alt-its. Okay, so I got an airplane here. It says an airplane pilot sights a life raft. Here's a little raft down here. At a 26-degree angle of depression. So if I'm this airplane looking down at this raft, this little angle here, because depression is below a horizontal line, that is my 26-degree angle of depression. Okay, it also says the airplane's altitude is 3 kilometers. So I'm 3 kilometers above the ground of my airplane. So my 3 shows ground to airplane. Obviously, that 26 degree is outside of my triangle, right? So we need an angle that's inside, which is why we use that alt interior angles. What would be my angle of elevation down here then? Because of the alt it. So I need to find a horizontal distance. That would be this little side. Let's call it X. From here, stuff we've been doing for a great while now. From 26's point of view down here, not the one outside of your triangle, one inside my triangle, is 3 opposite adjacent hypotenuse. Opposite. How is X related? Adjacent. What am I looking at?
Tan.
Tan. Tan of what always goes next to sine, cosine, tan? My angle, good. 26. 3 over X or X over 3?
3 over X.
3 over X. Good. How do I deal with X on the bottom?
Divide. Multiply.
Yeah, you can multiply by X and divide by tangent, or, as I like to do, swap them. X is 3 divided by tan of 26. Now what should I do? Yeah, ignore me.
Divided
Please pardon the short interruption here. This is for juniors. At this time, all juniors with the last names beginning with the letters A through the letter C.
Put it in your
please
calculator.
report to the library for the ACT
And what do we get
registration. Again,
for
juniors
X?
with the last names with the letters A through C, please report to the library.
3 divided by tan of 26.
6.15.
Okay, on a 6.2. You're good though. 6.2 kilometers is my horizontal distance. That's how far away my raft is from under my plane. Okay. Quick question. When do I know to use regular tan or inverse tan?
Trying to find
Angle
side.
Angle their side. If I use angle, do I want to use my inverse or regular? Inverse. When I'm looking for an angle, I need to use my inverse. Okay, if I'm looking for a side, I use my regular like right here. Okay, draw a pretty picture. Kyle stands from the base of a tree. So I got tree. Still Christmas time here, because that's the only kind of tree I can draw. And it was still horrible. There's tree.
Okay. Yeah.
And then, not good?
No.
Here's Kyle. Kyle's almost the same height as the tree, but not in real life.
Why do you do your triangles backwards all the time?
I don't know, it's just like backwards. Okay, Kyle is 120 feet from the base, so from the base of my tree to Kyle is 120 feet. The angle of elevation from Kyle to the top of the tree, so here's Kyle, here's the top, something like that. Angle of elevation is 40 degrees. I need to find the height of the tree to the nearest foot. From 40's point of view, how does X relate? Opposite. How about 120? Adjacent. No, I'm not going to give you a number guess, but a lot of times when we do angle of elevation depression, you're going to look at tangent. Okay, I'm not going to say always, but a lot of times you're going to look at tangent. Here again, we have OA, which is tan, so I got tan of 40 equals whatever what? X over 120. We like X's on top, because what do I do? Times by 120, I should take 10 or 40. Give me the nearest foot.
One 107 feet. Or 100.7.
So 101, rounding.
Yeah.
Right, yeah. Nearest foot. There we go. Okay, how are we feeling so far?
Okay.
Okay, great. I love that. Alright. A lighthouse. I don't know. Lighthouse. Here's a bulb. There's light. Lighthouse. No? You don't love this. Well. No? Where's John? You know, I'm not very focused. Well, dude, I don't know what a lighthouse looks like.
Like
Just
that.
literally the picture.
But, like, what do you want me to do?
You make a pole, like, you know.
Yeah.
That's not even.
Yeah.
Why are you putting a ball at the top?
Yeah, why's there
It's
The
balls?
light,
inside.
it's
in
raining
like a triangle thing.
Whatever. Alright, anyway, a rescue worker in our lighthouse is 135 feet above ground. So here's a dude up here, 135 feet above. He spots a ship in the water at an angle of depression of 62 degrees. So here's my little friend. He's not outside the lighthouse, he's actually in it. And we go down to the boat. Angle of depressions are below. Oh boy, that's supposed to be horizontal. This is rough. This is rough.
Did you make that boat?
No. Angle of depression is 62 degrees. I need to know how far from the base of the lighthouse is the ship. So basically, this distance.
Wow.
Well, first off, I need an angle in my triangle. What angle do I know?
62.
62.
By my ship, right?
Yeah.
So I got 62 degrees down here. How does 175 relate?
Offset.
X.
Oh, Jason.
What am I looking at? Tan of 62 equals 175 over X. How am I going to solve this?
175 divided by 10
over
175 divided by 10. Flip flop these. 175 divided by 10, 62. And round to the nearest foot,
93.
93. Questions there? Okay, this one's drawn for us, thank goodness. Because we can't deal with my drawings anymore. It's fine. Alright, suppose you stand 50 feet away from a wind turbine. 53, look at that. Your angle of elevation to the turbine is 56.5 degrees. Your eye level, so this dude right here, is 5.5 feet above the ground. I want to know how tall my wind turbine is. Notice, I don't think you can read it in yours, but in your triangle there, see we got a right angle here?
Yeah.
This distance is what we're going to label as X, because that's in my triangle.
So X.
So am I looking at SoCal or TOA?
Toa.
TOA, so I got the tan,
Whoa.
whoa, tan of
56.
56.5 equals X over 53, that's my fave, because I can just multiply by 53.
That is not correct.
What do we get?
80.
9 decimal? 0.1. Okay. Alright, but the problemo here, folks, is that I just found this. Right? I need to find the whole wind turbine. Well, why do you think they gave us this little step? Because from here to here, that's how much?
You just
Add 5.5. So take this 80.1 and add 5.5 and we get,
85.6.
oops, can't add. That's what you should get. 85. Okay, how do we feel? Decent? Question?